Draft physics video. It's so long. I haven't missed you, but I've missed the subject. I've been watching these Susskind lectures from about 8 or 9 years ago. New revolutions in particle physics, basic concepts. And what it really is field theory, quantum field theory. And it's basically Feynman diagrams, but done with this convoluted math instead, using a concept of annihilation and creation to describe interactions. So instead of mathematically thinking of it as a conversion, something moves into something, I poke something, my finger pokes some Play-Doh. What they do is they annihilate all the matter where my finger poked, and then they recreate it at the end of my finger in the rest of the matter, kind of a thing. So instead of doing what I think is the truth, which is the energy is converted, they use words like annihilate and create, which makes their whole theory about the annihilation of electrons with positrons suspect, because they use these terms loosely. Annihilate doesn't really mean annihilate. Create doesn't really mean create. And this is really sloppy, in my opinion, to break vocabulary this dramatically. So anyway, so they have this whole complex kind of math with these psi things and with daggers, no dagger, which is basically the compensation, the action and the reaction. So psi is the action, psi dagger is the reaction, and instead of calling it that, they call it creation, annihilation and creation. And obviously time is the effect, so this is why it's Feynman diagrams, because Feynman was basically doing the same thing and creating the psi and then the psi dagger, the opposite, and using a clock. Everything on that side of the 12, okay, is psi dagger. Everything on this side is psi. Kind of bullshit. Anyway, I don't want to. Obviously, these words are only going to mean something that people actually understand. This gobbledygook. So anyway, what I can glean out of it is this is the concept, and it's silly, in my opinion. It's this guy almost concedes. He doesn't say it outright. This is all just BS. It's a model that has nothing to do with really the real thing. Okay, we've used completely different things to duplicate the thing that we're trying to duplicate. So it's like there's dominoes that fall, and instead of using dominoes, they're using chicken legs or something, some other elaborate schema to duplicate the same kind of effect of one hits the other and hits the other and hits the other. But I'd say it's all convoluted. And it relies on things called the coupling constant, which is another. They use the small g just to confuse everything, to describe that, which just makes it confusable with gravity. But anyway, and these are where the fields come in, because each particle has its own coupling constant. And when you mix things like photons and electrons, that's when that constant has to be applied, because basically that's where you're mixing two different fields, because they think each particle has its own separate field of interaction, a clean field where conservation is obeyed, and then it's when these other reactions happen between the fields where all of a sudden conservation can't be guaranteed for some reason. But that's just can't be guaranteed mathematically, because they can't know where necessarily the effect went. And it did happen, it went somewhere, they just can't control either the math or an experiment well enough to be able to diagram that part. Anyway, so yeah, I'm irritated by this annihilation nonsense. It's just it's like the conservation. There's certain laws that I think are laws that you can write in the stone. The conservation laws. And there isn't anywhere in the universe where anything is truly annihilated. It's another fake word like spontaneous. Just shouldn't be used by physicists because it doesn't have an explicit meaning. It certainly doesn't mean what the word says in the general head when you hear the word annihilate. It might be like annihilating a planet where you'd see it explode or something, but annihilate like disappear? Yeah, no, things don't do that, and particles don't do that, and the quantization of energy has demonstrated that over and over and over again. So there's just no point. He even says things like, well, conservation isn't preserved. Well, it isn't in your math, but it is in reality. So don't say that. I just say it's really irritating. So anyway, the key thing that I really hate is this use of momentum being converted into frequency. And they're calling a frequency a momentum, which implies an energy, because the quanta are supposed to be all the same. If you're going to say two photons have different momentum, you're implying that they either have different mass, which you know not to be true, or they have a different velocity, which you also know not to be true. And so they just play this game with this frequency thing. Now, they don't give you explanations for where the nature of a photon's frequency comes from, how either it's produced, how, that's why they have to have a field. They have to have a field to have the interactions because they don't have any mechanism to convert one thing into another. Even a photon into a new frequency, they don't have no mechanism, so they have to create a field that this transfer happens in. So instead of just having two particles hit each other, they have to interact in a field, and the field has to tell them where to go. So we're back to this stupid bent space gravity model where the nothing is controlling. And it's not nothing. It's real stuff. It's real energy that moves the Earth towards the sun. Alright, so I have shown this before, I'll show it again. So this is what photons really are. They're quanta that's bouncing between charged particles. So if it's two electrons, they bounce back and forth. If they're an electron and a proton, it goes perpendicular, and then it can be, the effect is always goes somewhere. And as particles move towards each other, the big particles, the nuclear particles, not the quanta, but the nuclear particles, the mass particles, move closer together, the quanta between them bounce back and forth at a higher frequency. Less distance, higher frequency. See? That's the nature of the frequency of quanta. That's where it gets its frequency. So you can sort of understand that in a loose atom, the distance between the electron and the proton would be kind of fixed. That's the orbits. And so the quanta bouncing back and forth between those entities, like let's say the neutron and the electron, those quanta would have a fixed distance. That would be like your infrared radiation, that fixed distance, and it's the most abundant kind of radiation is heat, the most abundant form. So it would obviously have to correlate likely to a common circumstance regarding the distance between two objects. Now the distance, when you have like a nuclear radioactive element, you have a ton of electrons, very crowded, and so now you have probably electrons that are very close to each other, creating very high frequency quanta between them, and those are what's being released as your gamma radiations, your X-rays, and higher cosmic type frequencies, very high frequencies, because the electrons are very close together, and any jolting of them pushes them a little closer to each other, and causes a chain reaction or a reaction where quanta, like some will escape because the electrons will align differently, and quanta will escape at the frequency of the distance that they're trapped at. This model is perfectly consistent, and it gives you a physical explanation for where frequency comes from, why it exists, why light has it, why other quanta have it. Yeah, I just don't know why rational people, fair-minded, let's say there's fair-minded people listening to this video, I can give you a model that explains where the frequency of the quanta comes from. And it also explains why the particles are repelled and attracted. The same mechanism explains that. Explains why there's an inverse square law. I mean, explains it. You know, describes it, models it. That's it. It models it. All right. Now, yes, your mathematical models are dealing with the same circumstances, but in this hugely abstract way. But it's the same. I can show you where you know, your daggers are here. I can show you where your sine theta things are and your other bullshit, in the sense that I can show you the force mechanic. That something, for two things to get closer, something has to push them closer. And when they get closer, there's more energy in between them, in the sense that there's a higher frequency, which isn't really more energy, by the way. You know, it's still the same number of quanta. It's just that now you can release more of them in a given amount of time. So it's the time factor that really is where you store energy, with the amount of time it takes for the energy to actually get released. And that's how you can create a cushion. You can create a slowing down of the migrations, of the conversion of the energy. And that slowing down, going through more interactions, is what creates the idea of a storage of impacts or energy. Pressure. It's a storage of pressure. Alright, so I think that's the, you know, there's no point in beating it to death. I mean, I have talked about it before, and, you know, their model of, you know, who knows how many fields, 100 fields, functioning in some way, with photons moving this way and this way in their fields, the magnetic field and the electrical field, the electron field, let's say, and the graviton field, whatever it is, the magneton field. You know, I mean, Susskind even says the word graviton in this series. You know, again, a virtual graviton. Doesn't say virtual, it just says graviton, as if it's a real thing, when they deny the real thing and think it's a field. Alright, so I guess I'll read comments, and a couple of comments. There haven't been too many, I just don't have an agenda beyond just pointing out that the momentum is an illusion of what happens when you compress. The ping pong balls, if there's two ping pong balls bouncing between my fingers, when I push my fingers closer together, I didn't actually make the ping pong balls have more energy, but consequentially I've made the gun, that is my two fingers, I've increased its potential to release energy quicker. That's all. I can release more quanta faster when I have them bouncing at a higher frequency. So I haven't really increased energy. I've just increased a function. I've enhanced its functionality. I've changed its function. And I can create the illusion of energy in the sense that more movement in less time seems like more energy. But it's not really. Okay. So, on to the comments. This is probably just a couple. It really hasn't been, you don't make a video for a while and everybody shuts up. Anyway, so I guess I'll do the less crazy person first. I don't know. Hard to say who's craziest or most or entirely. Some idiot who promised to make a video, I don't think he did that. Human notoriety or whatever, notary. Anyway, so mindless marvels. I should do my best to get as much information as possible while I can. These are some really basic questions. Exactly. I remember you did talk about superposition of force. However, all it takes is for two opposite polarized quanta to hit each other at 90 degrees. Why can't that happen with forces? Well, it can. Let's say they, as I pointed out, if they hit head on, there can't be an interaction kinetically. One goes this way, one goes that way, nothing changes. But again, this is that polarized argument. So if they're of opposite polarization, that's where it gets a little more complicated. But that's the whole thing, why matter is different than forces, is because it's different. I mean, if electrons were just the field, then they wouldn't be called matter, if you know what I mean. So they obviously have a functionality that's different than the forces themselves. So they're the thing that makes it possible for the perpendicular interactions. The quanta has to be compressed, if that's what matter is, or expanded, who knows. It has to be one of those two things. It's either closer together or it's further apart, which creates the opportunity. I think it's just connected. They're closer together is the obvious, I think. One would suspect that creates more possibilities, having them smashed together. So everything travels through them kinetically and immediately, almost instantaneously, one could argue. But you wouldn't know. I mean, you certainly couldn't measure the speed difference between something going instantaneously through an electron and something passing right next to an electron, because that speed difference would be so incredibly tiny. So, but yes, it could be that there is movement faster than the speed of light, in the sense that when a quanta goes into an electron, it might come out the other side instantaneously. I mean, so we're back to annihilation and creation. And there may not be much delay in that process. Anyway, but I'm just saying, these are such simple rules, and yet you're griping by asking me these questions. Why? I could ask you questions why about all of physics. I could say, why do positrons exist? Why? It's the rule. Right? The 90-degree thing only happens when there's matter, an electron or a proton. And I'm claiming a neutron is an electron and a proton. Alright. Also, why do you say that an electron can't sustain velocity? If I shoot it in a vacuum, why wouldn't it maintain constant velocity? Well, you can't shoot an electron. So, see, when you say shoot, there's no shooting an electron. What happens is you have to have a positive conductor at this end and a negative conductor over here. You have to have a cathode and an anode. And you have to, you're not shooting the electron in the sense that you're creating a charge field and the electron is traveling in the charge field. It's an imbalance in the charge. And electrons always go where the positive is, the opposite color, They're always going to go that way because there's going to be more quanta affecting them coming from this side of the wrong color than from this other side, which has the right color, so to speak. The color that's invisible is coming this way. The color that's opaque is coming this way. And so it's going to move that way. But you're not shooting it like hitting a baseball. There's no shooting electrons freely. You just freely shoot one. You always have to use an anode. And once it passes the anode, let's say you have an anode or cathode, you shoot it. I don't know which one does the shooting, cathode. Anyway, let's say you shoot it and you're doing that trick thing where you have the positive charge, and then after the electron is moving, you kill the charge, and then the electron is free because now the charge is balanced. Its momentum will stop, and it will do what it does when it flies out of a piece of radioactive material. It will ground somewhere. It will find a neutral and go there. It will obey the local field dynamic and find where the lowest gravity is, so to speak, the lowest charge, the highest positive charge, and it will move in that direction. Or, if it's completely neutral and there's no impetus to move in any direction, it will just slowly lose its momentum because it's not a full piece of matter and it can't maintain velocity because it's constantly being bombarded by the gravitational field in the perpendicular, and that's constantly rebalancing this direction. So electrons have a problem where, let's say there's 3 dimensions, this way, and this way. Each one will be constant, the perpendicular to each dimension will constantly be rebalancing this. So it can never keep an advantage this way, because if it had any advantage, if it had extra going this way, then every time it got hit, it would get hit by more things hitting this way stuff than hitting stuff going that way. And so obviously the stuff going in the imbalanced direction, if it's getting hit balanced from the 2 sides, it will lose its imbalance in this direction. I have explained that in other videos, but it's something I realized, and I think it fits all the evidence that electrons don't maintain momentum. I can't shoot, even in empty space, I can't shoot an electron to a location like a photon. Just can't do it, even in a vacuum. You have to use a charged field to move the electron. Alright, took care of those 2, so I'll read this guy. It's a little, he wrote a lot of stuff, so I'm going to read it, but it's a little bit, there's lots of people who are critical of conventional anything. And so this conventional science thing is getting ragged on. What do you want, cat? I'm trying to do a video here, buddy. Yes, I am. Do you understand that? I don't think he understands. He can't hear me anyway. I'm talking to him. He's deaf. And the other cat's going blind, which is just so charming. It's just, I don't want to go into it. Alright, I am, like yourself, a theoretical scientist. I don't know if I'd even say that's what I am. I don't like any of these titles. I'm a thinking person, and I don't know. I just don't. There's none of them mean anything anymore. These titles. I'm obviously somewhat informed. I'm hungry for knowledge. But I don't know what to say. I'm logical. I think I'm that. Alright, like yourself, I'm thinking is very advanced. Like yourself, my thinking is very advanced. I would just never say anything like that. That just sounds... and frankly, it's not advanced thinking. As I've pointed out, it's more it's more primitive. Okay, I mean, not being converted into a religious person, let's say, is a lesser condition, not a greater condition. It's less information. So in a sense, not being indoctrinated doesn't mean I'm doing something more advanced. It just means that I'm not bullshitting. I mean, I'm not bullshitting about bullshit. I'm not thinking about bullshit, which is quite different than being advanced in mind. So I've said this before, garbage in, garbage out. This isn't really about having greater knowledge. It's about being able to tell the difference between bullshit and useful science or information, facts. It's about the difference between being able to know when to pull the trigger on saying something's a fact, knowing when you have enough evidence, and knowing when and when to be saying, no, let's think about it some more. That's really not good enough. I mean, when somebody tells you the nothing is something after all, and that it's telling planets what to do, it's time to say, let's try to do a little better than that. Anyway, I'll never get through this at this rate, right? Like yourself, my thinking is so advanced that it's difficult to get any kind of intelligent interaction. Well, again, if it's as convoluted as Susskind's math, well then, yeah, it's hard to do any interacting unless you're an indoctrinate. Unless you give a shit about this psi dagger bullshit and creating irrational numbers and never doing a formula with an actual number in the equation. Don't ever finish an equation. Just talk about like you get the right answer. Anyway, my fields of expertise, expertise is include evolutionary theory. I'm not too sure. Human evolutionary theory. Well, that's the same as evolutionary theory, but whatever. And atmospheric physics. Okay, especially storm theory. I don't think storms are. I don't. Frankly, I don't think there's a theory that should be classified as storm theory. It's really just energy in the atmosphere. But anyway, I've noticed for some time now that the currently popular theoretical explanations in physics is largely fictitious. Alright, fictitious, quote in parentheses, dualism, QM, bent space-time, string theory, multiverses. Yes, all of that is, QM, quantum electrodynamics, the original quantum mechanics, was perfectly sensible. It's this new crap that is, yes, crap. And, I would just call it too much wave theory, but yes, bent space-time, it's more like bent space and then bent time. They're two different things, and neither one of them is the correct answer. The reason my theory and your theory are hard for others to accept is because it's too mundane. So I don't really buy any of this. It just has to do with tradition. Okay, it's like if somebody suggests that the New York Yankees change their uniform into like bright pink, or something. People, no, I don't want change. I don't like change. No, I don't change. Tradition. So this is what they've bought into. People are apparently, physicists, comfortable with this mushy, vaporous description of reality. They are apparently comfortable describing a photon that arrives as a discrete, tiny quanta of energy as some sort of wavy blah blah blah, and that's okay with them. Yeah, so, and the rest of the population is too stupid to be able to make a judgment about it, so they get away with it. But they're just doing it because they have idol worship. Their idols say so. And you can see that because as soon as you say anything against their heroes, Feynman or something, they go berserk, insane in their overreaction. IOW, whatever that means, in other words maybe, reality is too mundane to serve as the basis for our understanding of reality in the minds of most people. Again, I don't think so. It's just that no one's forced to be accountable. So physics it's an ivory tower. They're protected from critique. They're protected from argument. They really don't engage in fundamental explanations for why they let go of this or why they let go of that or why they don't think it's possible to reclamate any other theory and blah, 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 blah. They're not challenged, and so it's the only game in town, so to speak, as a description of reality. And again, the public is way too stupid to be able to have the confidence to say, that sounds like shit. Essentially everybody but you and me, whatever. When given a choice between a fantastic but unreasonable explanation and a mundane but reasonable explanation, humans will always choose the fantastic and unreasonable explanation. No, they won't. We know that if people are educated, they usually don't believe in God, and so we know that, and I would argue that it has nothing to do with that. It just has to do with pop culture and pop culture memes. And so science is a pop culture toy, and and you just it's an emperor not wearing clothes, but you just don't get close enough to be able to yell it to the crowd and say he's naked. You just don't get the chance to do that. The reason for this are buried deep in human evolution. It's a little more complicated than that because obviously you can't. It's not like people are denying how stupid these theories are, but they can't understand it well enough to say, wait a minute, you don't have to use bent space. Wait a minute, you don't have to turn frequency into something called velocity, because that's stupid, or velocity into something called frequency, as they do with electrons. That's bullshitting. Alright, unreasonable explanation, mundane, unreasonable explanation, right. Anyway, no, I don't think, like I said, I think people do want the truth. It's just that it has to be grokkable. They have to be able to grab it and understand it. And kind of obviously, physics is layers and layers and layers of understanding and use of words that you have to be very careful about how you use them, and ideas like spontaneous and random, and you have to do you really do have to play with physical ideas and models to understand how nonsensical those words are, and so just it requires too much contact with the sterile physical facts, the experiments. And like I said, even when you have an intimate and extensive interaction with the experiments, you still can't see the real thing. You're only seeing symptoms. And so it's a little tricky diagnosing these diseases based on these kind of vague symptoms. Alright, the reason for this is buried deep in the human evolution. Well, I don't buy any of that bullshit. Our brains are perfectly capable of doing reasoning, but what we are is emotional organisms that are tied to traditions and bad habits. We're habit formers, and those habits can be in our cultural means, or those habits can just be in our individual lives. We sleep a certain time, or we sleep a certain way. You cut your food with a knife and fork in a certain way. You have mannerisms. These are just habits, and we don't like breaking We don't like doing the old dog new trick shit. One of the myths of human evolution is that the process produced a rational end product. Again, it's perfectly capable of being rational, but it has to understand that its emotions are bigotry. So, as long as it understands that because I don't like the color pink, it doesn't mean that pink is any qualitatively superior or less superior than blue or any other color. It just means I have a personal preference. And so as long as I don't skew the experiment because I have a hostility towards pink, then you're not going to have any trouble doing reasoning. But if your reasoning is going to be polluted by your psychology, in the sense that you think your psychology is always right, or that it's giving you good signals, then you can get in big trouble. This is not true. Humans are not rational, but can best be described as hyper-pseudo-rational. When you do hyper-pseudo, that can be best described as a colossal waste of time. You know, fuck that shit. You could just say irrational. This means that humans believe they are rational, but are oriented to intellectually create their own pseudo-reality. Again, pseudo-reality isn't, those aren't compatible words in my opinion. We model reality in our minds. Our models are made out of our information. Most people are terribly ill-informed about scientific realities, and that's bad. And on top of that, the realities are not going to be emotionally comforting, in the sense they'll basically tell you that you're a stupid programmed robot and not much else. The environment made you, you didn't make you. And the prevailing pseudo-reality can often become incorporated into a cultural and social contract. Well, that's the whole point, though. That social crap can be broken easily. It just requires the right circumstance, you know, the right man at the right time with the right phrase. You know, judge a man based on the content of his character, not the color of his skin. I mean, that kind of crap. I've said all this shit before. Irrationality is not a fundamental problem. It's just a problem in terms of the maturation of intelligence on Earth. We're the ones doing it for the first time. we can't do it from hindsight. We can't do it with the benefit of knowing how hard the road is, how easy it is to get distracted by unicorns and gods and fairies and bullshit. But we are learning that now. All of a sudden, everybody has a cell phone, and all of a sudden, the number of UFO sightings goes way down. Coincidence? No, I don't think so. This is the reason intelligent people like you and me that create rational but mundane explanations will unavoidably find ourselves at odds with science-based fantasy. Well, again, science-based. I don't know why you would even do that. But what it is sloppy science done by people who aren't like Newton, who wait until they know something before they draw conclusions, who understand the difference between theory or speculation well, it's the only story we like, so we're going to accept the three bears. We're not going to wait for a better fable. Clearly, the modern science has the horrible vice of premature incorporating things as facts way too prematurely. Human hyper-pseudo-rationalism, well, again, I don't think you're really getting anywhere. Well, you're not getting anywhere with me, you know, when you say something like hyper-pseudo-rationalism. That just sounds like phraseology. That's manipulative in itself. That's not a reasoned explanation. Doesn't require that hyperbole. It is the result of millions of years of communal selection. It's here to stay. Well, again, that's just such crap. evolution gave us reasoning capacity. It gave us an ability to model the real world because we had to know real things. We had to know that bears were different than squirrels. We had to know that, you know, bushes with prickers were different than bushes without prickers. We had to get it right to be able to navigate the world. So we have the capacity to reason. We have the capacity to model correctly. What we also have, though, is this terrible, selfish incentive, this valuing mechanism that means that some facts will seem unpleasant to us. They'll feel bad. It'll make us feel worry or fear if we have to face life knowing that there's no fairy godmother protecting me. When the rubber meets the road, she's not going to show up and make me a pumpkin coach or any of that shit, and she's not going to save the day, and I'm just going to be doomed. Yeah, they don't want to know that. It's sickening. I know I have made major breakthroughs both in human evolution and more recently in understanding of storms, especially severe weather. Oh, well, okay. Maybe I'll go see if you have some videos to watch. But there's a million of us, unfortunately. And although I can see the difference between me and all the rest of them, apparently other people can't. I'm right. And yeah, the Ken Wheelers of the world are just batshit insane. But I don't know where you fit. I can't make a judgment. But your language is a little scary, I'm just saying. Human hyper pseudo rationalism. That's twisted. The only comments I get from trolls is from trolls that are too dim-witted to realize the obvious cartoonishness of current storm theory. Yeah, well, I mean, that's obviously a specialty, so I don't, you're really going to have to go glean to see who you're talking to see what kind of expertise they have or what knowledge they have. Because, yeah, obviously, even Susskind probably isn't an expert on storms. Trolls are the rule, not the exception. Life is too short to waste it on dumbass trolls. Yeah, well, you don't really have a choice, so not much to say there. You do have to waste some time, especially when they start digging in and, shitting on your personal life and everything else. Alright, so the missing link of meteorology's theory of storms. Oh, not thunderbolts. Oh dear. This electric universe crap. Well, maybe it's something else, but no, thunderbolts is that electric universe shit. But we'll see. I'll go there later. But it doesn't look good. So they said, fuck you, troll, I guess, to somebody who he could see the comment, but I don't see the comment because the person is not commenting that I could see. Anyway. So yeah, probably enough of a video. I really do want to make some more videos. But this light wave stuff is just so... Well, like I said, it's just as bad as the bent space stuff. I mean, it's just the wrong-headed. And you can't use the field to create force. The forces are the stuff moving, and they're converted forces. So again, just think how much of physics is broken by the idea that they don't acknowledge the existence of the force of gravity, and they don't acknowledge its conversion into the motion of the earth, and that really what that conversion involves is the fact that the charge of the earth, the charge of the elements in the earth, are what's really causing it. It's a movement like a magnet, but it's not magnetism. But that's what converting a graviton into a magneton will do. It'll create motion, and that explains why magnets appear to be producing energy when they don't have any, they don't make it. So they're just not getting it. You can't think of like the sun and the earth doing something, moving, without there being some engine, something that's burning fuel. And the same with a magnet. Where's the fuel? But it's the same fuel. The gravitons are the fuel that makes the magnetons. And it's just so obvious. Damn. So anyway, they're real tons. And the tons we see, the photons, the ones we can measure, the radio waves, radiotons, are just in a form that's measurable. But like I said, the gravitons are in a form that's measurable too. We're just denying the measurement. We're denying our own witness to our own gravity as evidence of the force being real. Just as real as the photon of light. Alright, anyway. It just doesn't affect matter the same way. Well, anyway, been over it, but it's just getting so obvious that it's getting more tedious to have to try to think about how I have to go, how to explain something that just seems so obvious to me now. But anyway, and that's one of the most difficult parts of, it's like my years analyzing evolution. It's just so obvious how the functions work that it's just so hard to go into this whole explanation to somebody. Well, you know, you got to do the Dawkins thing. You got to first think what the bits of data on the chromosomes are doing, and they don't care. There's no compassion in that molecule. So if it comes up with something that appears to be compassionate or loving, you have to figure out that, oh, that's right, it doesn't have anything to do with that. It just has to do with surviving. Anyway, till next time and such.